I have now the pleasure to introduce to you another eminent scientist, also a chemist, which I think stresses the interdisciplinarity of medical, of health research which we have. It is Professor Ehud Keinan from the Technion. The Technion is a university, but I think it's more a breeding place for Nobel laureates. So very, very eminent scientists coming from the Technion, not only in chemistry, also in other fields, very recently also in computer science, for instance. And Professor Ehud Keinan is also the president of the International Union of Pure and Applied Chemistry. He is a professor of chemistry, of course, in the School's Faculty of Chemistry at the Technion. And he is going to speak about the global challenges and opportunities for Taiwan. And when we met before, he stressed that he does not approach this as a politician or in a political context, but that he takes the liberty to take this from a scientist and from an individual point of view. We are here to listen to you, Professor Keinan. Please.
Yeah, thank you very much. I want to follow up on what you said. Well, as president of IUPAC, I should say this, but as a scientist, that everything is chemistry, except theoretical mathematics. But everything is for a simple reason. All science is about matter, and matter is molecules and atoms. So everything is chemistry. Okay, so what I want, as mentioned, I'm not going to talk. Oh, I see it here. There are many logos here, and I'm not going to talk about. This is laser. Okay, about chemistry. Maybe one or two slides just to give you some flavor of what we do. And I'm not going to talk about IPAC. I want to talk about two topics. One is the general global challenges that we face, and then the relevance to Taiwan. And this is related to the reason we are all here today and this week. And if I try to use this, okay. A little bit of my background in terms of science. As you see, I'm a little bit irresponsible because I go to too many fields. And you see here some most of the topics that I've been involved with, all the way from organic, synthetic organic chemistry and organometallic chemistry to supramolecular chemistry and the biological consequences of that. And I want to show you just one slide because this is related to a work that I now collaborate on together with Professor Itsu Chan from NTU in Taipei. And I'll see if I can you operate this? It's a video, it's a small video. If you can push the button there. Yeah, okay. This is a mimic. It's a synthetic mimic of a capsid, of a spherical virus, like polio, for example, and many others are spherical. And all of them are made of 12 pentagons. This is the only way to make a sphere. So we made it from combination of synthetic pieces combined by 30 cadmium atoms. The yellow balls that you see here are cadmium, and you can see in the center, this is the pentagonal synthetic object. So we have now that, and we have much bigger than that, and we try to use it, apply it for immunization, because the immune system, when it meets a sphere, a spherical object, it goes bananas. Any spherical object is very immunogenic for obvious reasons. So we try to use this and attach the antigens to this object and get immunization. So that's all what I wanted to tell you about chemistry. I want to refer to the global challenges, and there are 6 of them. And the reason we have global challenges is the population. We call it explosion, but I refuse to call it explosion, and I'll tell you why. I don't think it's explosion by any means, although it looks exponential growth, and you see the line, and some populist, demonstrators say we should save the world, and all kind of slogans. This is not explosion, and we are. I'll show you later that right now we reach like 8 billion people. This planet could hold much more than that. We're not going to reach the big numbers, but this planet can hold 100 billion and even more. And I'll try to make my point. So this is how Earth environment looked like before human beings came over. And after human beings came over, it looks like this, the same area. And that's the origin of all the problems, that we live in densely populated areas, and there are consequences to the environment, etc. So the first one who got worried about this is Thomas Malthus, very famous. In 1800, he published his book that and he predicted that if the population, that time the population of the world was smaller than the current population of Europe. So he said if the population will increase by 10%, we're all dead, because there's not enough food. We cannot produce enough food on the earth to feed these people. Since that time, and he recommended stop getting married and stop having children, etc. Otherwise, it's emergency, okay? The population didn't grow by 10%. The population grew by more than 1,000%, and we are all happy and well fed, okay? So something happened to that, and we have to learn from this lesson. The number of, I do it by weight. This is the weight of human beings on planet Earth. We weigh 600 million tons altogether. Some countries contribute more. This part of the world contribute less, but per capita, of course. And the number or the weight of the domesticated animals is about half of that. It's about 300 million. So what is left for the wild animals is not much. In fact, this number is being reduced. Maybe now it's about 80 million, and it keeps going down, the numbers. I mean, that combine everything, whales and elephants and mosquitoes, everything that you can imagine. So it looks like not a very good picture, but what is going to save us is this number. We have 9 million tons of human brain on this planet, and this is going to save us. It's not only that we have that much human brain cells, but they are all connected, and that's the point. So I want to go quickly, and I don't have time. We can discuss it in details, and I combined 2 different lectures in this presentation. These are the 6 challenges that humanity faces. And these are serious challenges. And why they're serious? Because people, they cannot see easy solution to this on the basis of the currently known technologies. All right? My point is, okay, don't worry. This will be solved or alleviated by future technologies that we are not yet aware of because we cannot predict them. Okay. And those are 6, the 6 that I listed here. First of all, energy, and I don't need to dwell into this. The fossil energy sources are limited on the planet Earth, and we cannot use them because at a certain point in time they will be done, will be finished. Same raw materials. In fact, the raw materials is more serious and more painful, but has less public relation, certainly less than the climate change, which has a lot of public relation. But raw material scarcity is very serious, okay? And then we have food, and you see this picture that demonstrate the problem. So there are some people starving in some places on this planet, and water. Water, it's double. I mean, every such problem is not one problem, it's a package of problems. For example, with water, it's water scarcity and water quality. And the reason that, for example, maybe 80% of the world is living in places which is not water secure areas, because there's not enough water, and more than that, there's not enough clean water. So several million children die every year out of contaminated water, for example, the statistics. So, and all these problems are related. So you see, lack of water or quality of water is related to health, etc. Air quality, again, it's a multi-faceted problem. Of course, many people die from air pollution, from particles, okay? And more die from air pollution than from car accidents, for example. Part of the problem, of course, is the climate change, the greenhouse gases, etc., that cause the climate change. But I don't share the enthusiasm of many young people around the world, particularly demonstrators that shouting and claiming and go and damage museum masterpieces to draw attention because of the climate change, while at the same time they are completely ignorant. They don't have idea and a clue what they talk about. Okay, what is the problem and how the problem can be alleviated? So I'm not saying that climate is not a problem, but it's one of 6 problems. Okay, and we should not treat preferentially those that have more public relation than others. And of course, health, and this is the reason we are all here today in Geneva. So these are the 6. In fact, there's a 7th one, which is a human-created problem, and this is the, I would say, the risk and the threat to science. And this is something that I don't have time to speak about, but this is amplified by AI and by cyberspace, what is happening to science and how science may be jeopardized by what is happening in the, I'd say, cyberspace or digital landscape. Okay, that would be the 7th problem and probably the most difficult one to solve. So, my reasons for optimism are 4 of them. And I'll try to expand a little bit on every one of them. First of all, the knowledge explosion versus population explosion. I'll discuss this in a minute. Unpredictability of science. The evolution of network society and the personal liberty and human dignity. Extremely important. That people tend to ignore and take things for granted. And I'll try to explain what I mean by this. So, first of all, a world population doubles every 50 years. Human knowledge doubles every 1.5, which means 18 months. And I want to, maybe you don't appreciate these numbers, but I want to demonstrate why they're so important. And human knowledge, I mean everything you have in mind. Poetry, music, scientific papers, movies, bad movies, everything you have in mind, okay? So this doubles every 18 months. And you probably know the Moore's law, which is most, but it's a specific example of this 1.5 years doubling rate. So the power of a chip, of a computer chip, doubles every year and a half, and this is quite consistent for the since the 60s. But this is not the only one. There are several other criteria or things that double every 18 months, and I don't have time to discuss every one of them. And some people talk about, I like that some politicians or mainly journalists talk about a revolution, okay? It's a revolutionizing technology. We do this revolution or that revolution. And this is all nonsense. We don't have revolution, we have evolution. And some things, I mean, that you see, oh, something happened, okay. You see here, in this kind of representation of statistical data that you may be familiar with the stock market graphics, etc. Sometimes the market falls down, so people go and commit suicide. And sometimes it goes up and everybody is happy. But these are not revolution. This is local minima and maxima in something that goes and develops in well-evolving trend. And you see the trend. Sometimes it's logistic curves. Oh, again, I'm pushing the wrong button. You see the logistic curves, which means that one technology penetrates the market, takes the entire market to 100 and saturates the market, and then there's no reason to sell it anymore because everybody has this technology. Then there's another technology that is coming up, replacing the previous one, and again saturates the market. And the result is again the same thing. It's a trend, a steady trend. So what we see, and what some people call a revolution, which is pretty much like this Indian story about 7 blind people trying to identify what is an elephant, okay? So it's the same, you have to look at the big picture. And the big picture, for example, this is music recording technologies. And the old people in this audience may remember these plastic records, and you see every technology that came after that, like the magnetic tapes and then the CDs, every technology within about 10-15 years of appearance, it died, making room for the other technology that is coming up. And then we have the streaming, and every time we have a new technology taking over. The same thing happens with almost everything that you recognize from your personal experience. And I want to show here, it's sort of in a graphical way, the explosion of knowledge versus explosion of population. If we take, and I took the data from the Institution of History of Chemistry, if you take the knowledge of the human knowledge as 1 at the time of Jesus Christ, okay, the time of the Romans, that was 1. And then it doubled in about 1500 at the time of Leonardo da Vinci, so it became 2. Then it doubled again at the time of the Civil War in the United States or French Revolution. It became 4 and then 8, etc. And then the doubling time became shorter and shorter until it became, as I said, 1.5 years, 18 months. So what you see here in blue, that's the knowledge. And what you see in orange, this is the population. So it looks like population is exploding, okay, which is not true because this data is for 1990. If we go to 1999, you see the blue is already at, I don't see the numbers, 16,000, okay, which seems like a big number. But remember, it's going to double every 18 months. So if we go a little bit later, 205, it's already, yeah, you can see the numbers. I don't read it for you. And then if we go to 2012, you see it's exponential growth. By comparison, you see that the orange dots is already flat. Okay, no explosion and not, I mean, explosion is non-existent, a human explosion. And if I go 2018, it's 68 million. And I say the number one is the knowledge, human knowledge at the time of Jesus Christ, okay? And now we know 60, or not now, in 2018, we knew 68 million times more than those people, the Romans, knew. And then if we go to 2000, our time, it's already 1 billion, over 1 billion. And we don't, we can keep calculating. By 2030, it's going to be 17 billion. Okay, so the world in 2030, which is around the corner, will know so much than we know today. And the meaning is that it's very naive and false to believe that we can predict what's going to happen in 2030. Okay, we cannot. So by comparison, the world population every 50 years, doubling time for knowledge is 1.5. What's the meaning of that? That's the number of scientists doubles every 15 years. And there are about 6, depends how you identify scientists and technicians and engineer. There are about between 6 and 60 million of them. But the most amazing consequence is that out of the all scientists and experts that ever lived on this planet, including Archimedes and Leonardo da Vinci, everybody, okay, about 80 or 90% of those, they have email address and they're living with us today. Okay, that's an amazing, and they probably get a salary. So that's an amazing consequence. Now, the second issue for my optimism is the unpredictability of science. And I don't have time to read to you all these quotes from famous people. I just go quickly. For example, Bill Gates. Everybody knows Bill Gates. And he says that everyone will probably be happy with the 640K. Okay, Bill Gates is not stupid, of course, but he said what he said, and other people said what they said, because they thought they could predict the future. And as I said, nobody can. And here are some hilarious quotes, like Lord Rutherford, who discovered the nucleus of the atom. He said that the exploitation of that discovery for anything beneficial or useful is non-existent. Okay, so of course this is nonsense. And what these people say. And again, these are Nobel Prize laureates and people who know what she's supposed to know, like Astronomer Royal. They say that space travel is a stupid nonsense. Space travel cannot happen, all right, by famous people. I mean, these are not, street poll, all right? Most importantly, look at the date. We talk about 1956. And let me tell you what happened shortly after 1956. 5 years later, Yuri Gagarin was already in space. All right? So I'll show you later something even more funny about these ideas of people try to predict, particularly politicians. And this is a case of a politician, a very good one. One of the best presidents ever served the U.S. Nation, even better than Donald Trump. is he wanted to predict, in order to know where to invest the federal money, he wanted to predict what's going to come in the near future. So he collected a huge commission of about 300 top engineers and scientists and asked them to tell him what's going to be the future in terms of technology that is coming up. So they say that the agricultural research, this government should invest in agricultural research and do synthetic fuels, which, by the way, the Germans already did it at that time, but the Americans didn't know about it, the Fischer-Tropsch process. But what they missed is more important. They missed the nuclear energy, they missed the radar, they missed the laser, they missed the transistors and the NMR and personal computers and this that I mentioned earlier, and all the jet aircraft and rocketry, and of course fax machine and synchrotron radiation and the synthetic polymers, synthetic fuel, etc. And I can keep going with technologies that they never predicted, they could not predict. Genetic engineering and genomics that were mentioned here, and so on and so forth. Of course, organ transplant and spare part surgery. I mean, all these things were out of their reach and out of their prediction. Now, remember, there are only 131 years from the invention of Graham Bell to the iPhone presented by Jobs, okay? And that's amazing. It's 130 years. So it's not that we went for something that was, at that time, was revolutionary, if I can say this word, until we have something that was totally unpredictable at the time, okay? People may think that the future is an advanced version of the past. Most people think this way. And again, if I look at the aircraft industry, so only 103 years went from the Wright brothers to this F-35. So even, I'm not talking about 1903, I'm talking about, let's say, the early 90s or 80s. Anybody could predict such a machine like the F-35? Nobody could predict, okay? And if you look at the technologies that are developing, you see that, and you can read for yourself the various technologies. The most important thing is that they come closer together, and the lines of saturating the market is much steeper from one to another, which means that in the future, again, if I can make any prediction, I don't know what technologies will come. Nobody knows, but what we can be sure of, that they will come in even more denser and steeper versions. Things we never dreamed about, they are around the corner. And I like these cartoons because they were published in January 1900 by the German chocolate company. They put it in the boxes of chocolate as some kind of a souvenir, trying to predict the future in 100 years. So this is how the world will look like. I mean, the people of 1900, this is how they predicted the future and the year of 2000 will look like. And you see that they thought it's going to be an advanced version of the past. Like in the upper left corner, you see a sort of hybrid of a train and a ship. Very clever, right? But this is not the way we go overseas, right? And other things like you can see all kind of stupid things like a hybrid of a hotel and a train and several other things. What I'm trying to say here is that if we think of the future we should remember that the best we can do is this kind of cartoon. And what will happen in 10 years or 20 years' time is going to surprise everybody here. Now, the third reason is the evolution of interconnected brain, and I have to rush with these numbers. There are 2 points here that I want to make. First of all, of the number of internet users worldwide is coming to a situation where almost everybody is on the internet. And most significant is that if you look at the users of smartphone by region, but you should also look at the total number. And the total number is 7.5 billion. Okay, what does this mean? It means that everybody has an iPhone in his pocket, including people who cannot afford having pockets. Everybody has iPhone, which means that everybody is connected. And this is like in the brain, that we have many neurons connected to one another. In the society, we have this people connecting together. So I think I'm going to rush. This is about human dignity, and sorry, I have to rush. Why this is important for development and for science and everything else that we want to achieve, like medicine, because in non-democratic countries, this is how people or scientists look like. If I use this as a metaphor, they are allowed to look in a certain direction. They are not allowed to go and look and search and follow their curiosity in directions that may be forbidden or they assume they make somebody unhappy. In more democratic countries, this is a better metaphor of creative and innovative scientist. Has no limits, has no boundaries, and just goes against, break the rules, etc., which is very difficult to do in non-democratic countries. And the result is that you see that almost all Nobel Prize laureates are coming from democratic countries. And Israel, we are very happy, for example, with these 6 Nobel Prize laureates that got the prize within 1 decade. And I'm very proud of these stamps, because I designed all of them. They are Israeli stamps commemorating the Nobel Prize laureates. And I'll just go to the good news, and you see the things that are positive indicators and negative indicators over the last 70 years. Okay, it's not just a revolution or one step in over a few years. This is how the world looked like at the time of Thomas Malthus, that 95% of the population were working, making food, producing food by agriculture. If you ask how many producing food by agriculture today, I can ask you the question, but we don't have time to do this poll. I can tell you it's only 2% of the population work in agriculture, but only half of them produce food. The others produce something else. And the top crop in the United States is not wheat, is not corn. The top crop in the United States is this grass. Okay, that's crop number 1 in the United States. So this doesn't look like a starving world. And in India, for example, there was a great famine in mid-40s. But a little later, after the Green Revolution, India became an exporter of wheat, of grains, which is amazing. And we're now facing, maybe as most of you are not aware, we are facing now the second Green Revolution, for example, by technologies developed by Chuan He from University of Chicago, leading to controlling the expression of gene. So I go quickly and water. This is when energy becomes cheaper and more available, like by harvesting the sunlight, water is now becoming available. And this is a typical example that I bring from Israel. About 80% of all water in Israel is desalinated, and not only for the use of Israeli people, Israel exports water to the neighboring countries. So we are already supplying 40% of the water in Jordan. And pretty soon, Israel will supply 60% of the water consumed in Jordan, produced by Israel by desalination. Think of the geopolitical consequences of that, and how stable is the peace treaty now between Israel and Jordan. You cannot break it, right? So I would like to go to energy. That's coming from as you see, from sustainable resources, mostly from sunlight, but also wind. And I'll skip this. Air pollution, of course, we are getting into a better world. And I'll skip this, and this has the implication on the workforce. The way production was done in the past is not the way things are being produced today. So with this, I have a problem here, and I want to consult with you. I finished this, but I didn't have time to speak about Taiwan. And if we don't have time and I have to finish here, I'll show just one slide. All right? Is that okay? Okay. So I'll skip all this. This is just trying to say that the world is much bigger than the nominal square mileage or square kilometers for the reasons shown here. But I don't have time to discuss it. And yeah, this is one slide that related to Taiwan, and this is important. The world has 9 cultures. This is the book of Clash of Civilization, very important book. And you can see the Asian cultures are Chinese, Japanese, Buddhist, and Hindu. All these, I call them the Asian cultures. And Taiwan is lucky because Taiwan is a mixture of 3 cultures. And I try to show it here. I still keep the color code of the 9 cultures. And you can see Taiwan is a mixture of 3 cultures, the Chinese, the Japanese, and Western. And we can talk about this. But in a metaphoric way, this is like production. It's a unique event in human development and geopolitical development. It's unique, and it's somehow related or similar to production of gemstones in nature. It's a very rare event. That's the reason gemstones are so expensive, because you need specific conditions of temperature and pressure and humidity and rare elements, etc. So this is Taiwan in my demonstration of all the 3 colors, 3 cultures. And I know that we have telepathy with John Lean, because he selected the design of his tie this morning according to this. Okay. Yeah, and I just want to go, I'll skip all this. I'll skip all this and go to the final thing. These are important things, but I don't have time to talk about. I come back to why Taiwan, and you know, of course, all these issues of why Taiwan is a medical superpower, and I don't need to read this to you. Of course, the contribution to epidemic resilience and the being top in terms of public health and sharing knowledge and teaching many countries how to deal with the medical challenges. So all these are known facts. And in fact, there isn't or the position of Taiwan on the global map in terms of medicine is such that ignoring Taiwan for whatever political reasons can be defined as simple stupidity, because Taiwan keeps developing anyway. The development of Taiwan and the medical sciences and technologies in Taiwan is not dependent on the approval or disapproval of other countries. So therefore, I took the liberty to change the logo, because Taiwan can help. This is a proposition. This is the past, but it does not reflect the current situation of Taiwan on the global map. So I took the liberty to change it to this one. Taiwan helps the world already. And it's not a problem of Taiwan that Taiwan is not part of the UN whatever bodies. It's a problem of WHO. WHO can benefit from Taiwan, and if it does not want, it's their problem. It's not the problem of Taiwan. All right. So that's easy, and sometimes, and it's very important to remember that human values and human health stands above politics. So I could say many things, and there are other things I want to show if I had time. This is probably, I don't know if, maybe I'll say a few words about this episode, because this shows how ridiculous and stupid could politics become. There's a Holocaust Remembrance Day. There's also one by the United Nations every January 27. This one happened a different date in Israel. This is earlier this month. Now, this is a very small communal Remembrance Day. It was done in the city of Haifa, and it was organized by NGO that take care of Holocaust survivors. There are quite a few of them in Israel, most of them over age 90. So they had this serious, sad kind of ceremony, and the organizer, the CEO of this NGO, shown here, he invited many representatives from many consulates and embassies around Israel, and they came. One of them was the representative of Taiwan to Tel Aviv, and she is shown on the left photo. And all of a sudden, there was Chinese diplomats that came to him and told him, we are not happy with the Taiwanese delegation here. He said, well, I invited many countries to everybody who wanted to come, and they come and they honor us. He said, yeah, but Taiwan is not a country. So he said, look, I'm not here to be involved in any politics. I mean, this event is not a political event, and we talk about human values. So I'm not going to tell them to go, if this is what you mean. He said, yes, I want you to let them go out and leave. He said, no, that's not going to happen. So the delegates from China left, okay? So that's the story. Now, what is the consequence of that is that politics sometimes, or the old politics of probably the last century, can become ridiculous, okay? When it becomes ridiculous, it becomes obsolete, and that's coming next. So with this, I want to stop here, and thank you very much for your patience.
Thank you very much, Professor Keinan. And let me say, I was really amazed in this time of all those doomsday scenarios to use science and your scientific perspective to really produce a philanthropic view on this world and not a misanthropic view. And I would like to just to thank you for that, because I think wholeheartedly I felt this was necessary, useful, and correct. and it gives us hope and also a challenge to work, not to give up, but really to look into a future. And as you said, the future is not a recreation of or refurbishment of the present. It is something new indeed, and at the same time, I think a logical consequence from you is, and I hope this is correct, it is not a non sequitur, there is also no way back. So we cannot save this world just by going back and saying, gluing us to the walls in museums or on the streets and saying we're not doing anything and you have to stop. That is not the answer. The answer is going forward and really planning the future. We have a few minutes now. Oh, let me first once more thank you for this wonderful presentation.